ByteDance for inviting us for your Cloud Native meetup in Singapore. I really appreciate it. So we're going to talk about fast analytics with Presto and Alluxio, and then we're going to explain to you why we're going to work on that. So, okay. My name is Jasmine. I run the open source community effort at Alluxio, together with my partner, Bin Fan, who's going to come for the second part of the talk. He's the founding member and a VP of open source at Alluxio. So the topic today, we're going to talk about precisely the Presto and Alluxio. So I'm going to give you a quick view of what Presto is. Most of you who ever worked on SQL query engines, you're probably already familiar with it, so it won't be too dubious. It is a pretty popular SQL query engine, and then it is actually heavily used with Alluxio. Most of the Presto users nowadays will use Alluxio together. And then we are working, have deep collaborations and joint development deployments in production at large scale with Facebook, Uber, Twitter, Tencent, TikTok, many companies. I think that's why I'm invited to ByteHouse. So we'll give you a deeper dive on how those collaborations work later. But before we get into that, most of you might not know what Alluxio is, even if you know what a SQL engine is, because we're not. So we are an open source project, as well as a commercialized company. Since I'm mostly responsible for the open source side, I'll talk more on the open source part. The open source project started back in 2014. If you look at where we're at now, we have more than 1,200 contributors who actively put codes in our code base, right? And then we have more than 9,000 people in our Slack community channel. We're also ranked one of the most important Java-based open source by Google and OpenSSF. And we're also ranked as one of, the GitHub's top 100 most valuable repo out of the 96 million. So for those of you who are working on open source, I do encourage you to check Alluxio out and become a contributors. So what is Alluxio as a product? Since I said many of you, what we are is we build a large distributed system that is a new layer that sits between the compute and then the storage. And then this system provides a complete virtualization across different all data sources. And then we're also application across different application across environments. We're environment agnostic, which means it doesn't matter where your data is stored. It can be on-prem, hybrid, in cloud, containerized. We do have two versions of Alluxio. Like I said, we are open source projects. We definitely have a community edition, which is free. And we also do have an enterprise edition, which helps to bring revenue to the company. There are a lot of thousands of companies that are using Alluxio today across different verticals, and with technology company leading the way. And there are also financial companies and then other financial services, pharmaceuticals with stricter security needs that are also using Alluxio. All right, since I was invited because we run the open source, and I think there's some of you who might be interested in how you run an open source community, this is where the part I would cover. If you are a product manager, you might be familiar with the concept of flywheel. What that is pretty much you want to have the system, you build a system such that you can encourage growth automatically once you give the right input. Now, this concept is also adaptable in open source community setting when you're trying to grow your community. Now you see two graphs here. If you look on the left one, a lot of times when people look at the open source community, you dissect your users or your contributors in groups of three. You call them new members, you call them users. Users are not necessarily contributing back to your GitHub. And then you call them contributors. But just having contributors is not necessarily able to bring you new members. So again, we tap back to the concept of flywheel. The idea is if you have happy customers, they're going to tell their friends, they're going to refer friends, and they become new users, right? And they all buy your products. In the community case, ideally, you want that contributor to bring back new members, but that's actually not enough. So there's a small group in the contributor that we identify them as super contributors. And what you want those people to do is advocate. By them helping you to advocate your product or advocating your open source project, only then you can find new users. So they can actually help you discover new users. So if you look on the right side, that graph is completed, and that's the open source flywheel model that at least that Alluxio is adopting, if you guys are interested. All right. when we were talking about super users, so what are super users, right? Super contributors in your community case. So those might be your community champions. They're a technical expert. They could be your, they could also become your economic buyers. They might start with open source, but eventually they might be your champion inside the other company that helps you to lease a deal if you're on the marketing or sales team. And they can be a lot more than that. And some of you who are been working on an open source community might also be familiar with different tiers of them. You can be contributor, you can be committer, you can be a PMC member, you can be a PMC maintainer. Those are all different levels of what you can do when you join an open source community and start contributing to it. So for us, the super users could exist in any of those layers. They don't necessarily have to just contribute to code. Some of them, if they're your super users and they're willing to come out, for example, at this event and give a talk about your use case, those could also be your super user, super contributor. All right. So I want to give you a few examples of super contributors, what they can do, and it's also to leeway to what we're using with what we're working with Presto. So one of the example is called special interest group. Now, if you are a owner of an open source community, it would be your job to organize a special interest group. What are a special interest group? In Alluxio's case, for example, we work very well with Presto. We may have a special interest groups that specific focus on that topic. So those are the users who are only interested or majorly interested in how Alluxio work together with Presto. We also work very well in a machine learning AI scenario, right? But that's very different than the other group. So we form another group called, machine learning scenario, like special interest group. Then we probably have bi-weekly developer syncs online and offline for those, so that those people who are those technical contributors who are interested in those subjects, they can help to lead the discussion. So those are special interest group. There's a lot of work that coming out of the special interest group. The example I'll give here, we actually give birth to another open source project from there, and encourage a lot more collaborations. And then the other type of super contributor, like I mentioned earlier, they could become your economic buyers. Here, if you are working on, I would say, on a product team or on the developer or on the open source team or on the marketing team. So what it needs to make the super contributor from using your free version of a community edition to your paid version of enterprise edition, it does happen. It only takes, the only thing is it does take time. It's critical for you to have a good developer education program, and also to make them, if you're in a product, you have to have a well-defined differences between your community edition and enterprise edition. Those two groups are usually quite different when they need, when it comes to their product needs. So they were figured out, but you have to do the education first to have them know what's the difference between your two versions, right? And then your revenue will come. And then a third example I want to give you is cross-community collaborations. Those will eventually leeway to what my partner is going to talk about on Presto, since that's the topic today. So the cross-community collaborations are something like, if you already run an open source community and your open source tech stack, no tech stack works on its own, right? So it always works with something else. That nowadays, there's a lot of other open source technologies that work probably very well with yours. In Alluxio case, Presto works really well with Alluxio. If you're a Presto user, you'll get a lot of benefit for that. So the collaboration with the Presto community actually started way back when Facebook started this project, and Facebook now called Meta. The Presto team has been sort of a key player in this cross-community collaboration with our team. In particular, Ben back then lead the engineering effort with the Meta team, with the Presto team in Meta. So we did a lot of engineering work that Ben is going to show you later on the technical front. So one of the projects we built is called RaptorX, and then that one is widely adopted at Facebook right now. And then through that process, what we got is, for example, if you think about it, those Presto contributors. So back then they're developers, right, in Facebook. Before that collaboration started, they were not even Alluxio users. But throughout that process, they went from non-Alluxio user to become our super contributor. So that's one of the gain that we have. And then we were, through that process, as the open source owners, we were able to tap into another community, a top tier community back then, backed by Facebook. So we're able to observe how they run an open source community. We get access not only to their community, but also to their committers. Throughout that process, we also made new friends with their team who are very passionate about open source, who are also technically strong. And then better yet, for our own engineering team, we tap into the talent pool, or the people that are collaborators. I'm glad to say we actually have quite a few recruits coming from that team and a collaboration as well. And then once you've done that process, once you mature how you do a collaboration, cross-community collaboration, we established this process playbook. And now this playbook is actually being used for our collaboration with Uber, with ByteDance, with Twitter, and a few other companies. So that's my part. I'm going to pass the mic on to Ben, who talks specifically on Presto and Alluxio.
Thank you, Jasmine. So in the second part of this in this presentation, I will cover more on the technical side, like why we started to do something with Presto and Alluxio, this stack, and what we do and where we're going. So back in 2019, like one day I was in a meetup. It's actually a Presto meetup, and I met engineers from Meta. At that time, Facebook. They told me, "Hey, Ben, we are redesigning our Presto architecture." Well, the reason is Presto is well known to be a very federating the SQL queries, and it's very well known to be just like a SQL engine with the super ability to connect to different storage and to different data sources. Well, it works well until they are fully embracing the disaggregated compute and storage architecture. So in Facebook, they are having this one, they call this one remote storage, and they call it warm storage insights. And if you just repeatedly go into the remote storage to fetch all the data, which is cool because you get all the computation engine and the storage engine, they can independently scale. So you can just, oh, I need more computation power, I just add more Presto nodes, or I need more storage, I just add more storage nodes. So they can compute, and storage can be disaggregated and grow independently. However, this creates a lot of trouble in creating the data, getting the data, so high latency when the compute storage are not in the same region, not fast enough for low latency network workloads. So actually at that time, they want to really enter the low latency workloads. So prior to that, the Presto is not really used for queries on the latency of few seconds, but they really want to go that range. Also long varied tail latency, that's what they see. So they have some internal optimization first, like they have some project called the Raptor. Before the Raptor X was born, they called it Raptor. And the Raptor is a way to migrate data to some place closer to Presto. And so they can query data locally, but there has a lot of like a hard-coded requirement there. So it's not very flexible. And that's why we come up with like hey, how about just like you put Alluxio here? So a Presto can be an app layer of Alluxio, which is layer to fetch data, federating data from different storage in here, also including Facebook storage. And then you use this as a layer to just repeatedly query your data, the hot tables, and gives you very good cost efficiency and performance. So yeah, that sounds good until, yeah, they found, hey, Ben, we cannot do this. In Facebook, we have a lot of requirements to deploy another service here. It's going to be very hard. I won't quote which project, but they told me, hey, for this very, very famous project, it takes us 3 years to get it in the production because there's a lot of just process to complete. So how can you help me here? I really like your technology. I said, hey, in this case, let's have something special for you. Okay, so what we do is we get a co-located Presto with Alluxio, co-located Alluxio with Presto, but even further, we actually we get this called embedded version for Alluxio with Presto. So I started this project in early 2020 when I was in Hawaii on my vacation and started writing documentation with Facebook engineers together. And we take us like 6 months or so to really scope the project, and together we try to leverage a lot of existing source code, a lot of existing infrastructure. So in the end of the day, we get you can think it's library version for Alluxio to be included in Presto and to manage their SSDs. And they can still use the HDFS Presto can still use the HDFS interface, so they can transparently to query the data. But if the data is hot, this library, the data cache library, will just get data. And this is some technical details. We use a page, we use a small size, and we got so get data locally to Presto. And we have this automation to avoid manually evicting data. There's a lot of troubles during this process. Like for example, I fixed a bug and I realized it's a kernel bug. So the thread is actually reading something and never get a return in the Java land. And we have to prepare things like that. So when this is running in the Facebook scale, you see all kinds of weird stuff. And you have to, just like in the production environments, you have to learn what's really going on. One thing is really interesting, like the locality-aware scheduling. They call this affinity schedule, soft affinity scheduling in Presto, which was actually added by Facebook engineers to work well with this. The idea is, like, I'm one of the Presto worker, and I need to do some work. So this work tells me to read the data A. Fine, so Alluxio helps me to get the data A and cache data A here. But next time, if there's another job, there's another work, requires reading the same file, but assigned to a different worker, then all the cache is not really utilized, right? So they have the locality-aware scheduling algorithm to try to really maximize the data affinity. So for the same type of work assigned to the same set of workers. Yeah, anyway, there's a lot of details. I won't go there. So this is the configuration. Like we can configure the page size for 1 MB. Each 1 MB is stored as separate. This is technical details, supports concurrency reads and worker restarts. Actually, yeah, there's another interesting story. So in the beginning, we set this. You can think this as a caching layer to be a very blocking call. If you have a lot of data restarted, stored on the SSD, and you restart, actually they're using huge disk. And after you restart, it takes a long time. Actually, in their case, it takes 30 minutes before you read everything from the disk, so you can just start to query. So what you're thinking that way, like I restart my Presto worker and it takes 30 minutes before I can do any query, that's not acceptable by them. So they said, okay, then can you help me to resolve that issue so we can start to do something, even it's not the best situation, but at least I can do something. So okay, I said, let's do this. We enter a read-only mode without doing any caching work there, but we can start to serve, so without blocking them. So anyway, a lot of optimizations because there are requirements in production. And this is the Presto affinity scheduling added by Facebook to work well with this feature. And they use hashing to two preferred workers. So when you split a Presto slip, and this is prevent the case I just mentioned before. So it maximize the chance if you read the data repeatedly, you hit the same worker, Presto worker, and you utilize the same cache data. Okay, so they had some experiments. They show that in the Facebook workload, they see very good results by having this configuration. It's actually now it shows 600 nodes, but right now it's 10 times or even multiple times larger than the deployment. And we have a significant improvement in the latency. So this is basically the latency with the, even for P95, for P95, we see almost 50% reduced improvement. Okay, so this is what called the Raptor X in Presto for Facebook. And this is architecture. So basically we embedded a special version Alluxio there to make Presto work better. Okay, so this is not the end of the story. This is just the first iteration as mentioned by Jasmine. There's a collaboration. Once the collaboration kicks off between two communities, where there's a lot of new things going on. So during this process, I realized there's something they really want to get understanding, which is how much resource I really need to allocate to my Presto worker as a caching space. So they have certain ways to, so Facebook is just super rich. So they say, okay, never mind, let's just allocate a large amount, a huge amount there. So you can get enough caching, but we want to evaluate whether this is the best for the storage efficiency. How to evaluate that? Then they talk to me and they say, okay, let's work on this. How do I estimate the working set size? And this turns out to be a research problem in the past few years. There's quite a few papers in NSDI or in some other conferences studying this. And but a lot of them are just very complicated, and it requires extra overhead to do this. So what we do is we created an algorithm called shadow cache. It's based on my PhD thesis, and so I created a cuckoo filter. So based on this PhD thesis, they added some extra information to a cuckoo filter, so we can track how much resource, how much like a resource is used for what in a probabilistic way, because it's not really accurate, but with a very high accuracy. I don't want to go to details, but okay. So this is how we work together with Facebook. Later on, Uber guys come to us and say, hey, Ben, I see you guys are working well with Facebook. I want to do what you guys are doing. So how can we collaborate? I said, okay, I'm cool. Like this is really cool. If we can get the same set of algorithm, the same set of architecture works for not only just like one user, I really want everyone in the industry use this. So we started more collaboration with other people. For example, this is talks about the in production for Meta for almost 2 years. And we started, it's also in production on Uber. I think Uber is in the middle of publishing an article this. So it's interesting, like although the problem we're trying to solve is very similar, but there is a subtle difference and creating some differentiation. So for example, in Uber, we found they are very tight in the caching resource, how much storage resource you can put. And they have if you just do this blindly, then they have a really bad, so their working set is super large. It's larger, much larger than the amount of storage they can assign to this Presto fleet. So we have to do something very careful, like what data can be included in the cache. So we did something called a cache filter, which is basically implementing a admission policy, like what type of files you can include. And also they are dealing, actually, another interesting thing is they're dealing a lot. So in Facebook, they're dealing a lot mostly with static data. Once the data is written in their remote storage, it's never changed. For Uber, they're dealing a lot with the hoodie tables. If you're familiar with hoodie tables, it's a lot getting updated from time to time. So yeah, so we have to come up with some way to handle this situation. Otherwise, we found there's some issues, corner cases we cannot cover. So we use the file path and last multiplication time to compute the hash. So the latest partitions are cached. This is just really just for the hoodie tables. Okay. Benefits from collaboration, it's basically from Presto. This is what we learned afterwards, not only just for one company, but for multiple, for the community. Yeah, so from the Presto users, they can get a dedicated caching solution, and they get basically they can leverage another open source to do something. And for us, we get a better understanding of the user's needs, and we have tighter integration for allowing more performance optimization, and we can we're even investigating more and deeper integration. So it also a very cool process for me to experience, like how do you land something at the Facebook scale. Ongoing collaboration, yeah, these are the some work we're doing, not really actively. I don't think we're actively working on this right now, but some of them. Yep, that's the end of my story, concludes my story. Any questions? I'm waiting to take from the audience or anything from the bridge. Okay. Nope.